Let's go through the questions. Question first. A car of mass m kg is towing a trailer of mass 300 kg down a straight hill inclined at 3 degrees to the horizontal at a constant speed. So at first we have to draw a well-labeled figure. It's not necessary. There's no mark for that, but actually if the diagram is well and clear, so it'll be easier for you to find out or deduce the equations that are required to solve the question. So an inclined surface and the angle is 3 degrees with the horizontal. 3 degrees with the horizontal, and a car of mass m kg is towing a trailer of mass 300 kg down a straight hill. So that means the car and the trailer, it's moving in downward direction. So that's the car, say for example, and that's the trailer. It's moving in downward direction, and the car engine needs to spend 40,000 joules of energy for overcoming resistive forces for 50-meter length. So resistive force means air resistance, frictional force, everything is there. Okay, so and the car and the trailer is moving with a constant speed. The engine of the car is doing no work and the tow bar is light and rigid. The engine is not giving any additional forces. So that means the car and the trailer is moving in the downward direction because of its component of weight along the plane, along the surface. Okay, so what we can do here, at first, let's find out the resistive forces. So we know that work done equals to force into distance moved in the direction of the force. Now here, work done due to resistive forces is 40,000 joules, and force, resistive force, we don't know that, and that work done was for 50-meter distance. So from here we can find out the resistive force, and that's going to be 800 Newton. So we have got the resistive forces, and the engine is not doing any kind of work. So an object is moving with a constant velocity. So that means the resultant force is going to be 0. The resultant force on the car and the trailer is 0. So that means the downward force component of weight, which is mg sine theta, or mg, not mg actually, because the total mass of the car and the trailer is m plus 300. So m plus 300 g sine theta, or g sine 3 degree. G sine theta or g sine 3 degree. For now, it's not required. The resultant force along the plane, will be m plus 300 g sine 3 degree equals to frictional force, resistive force, that is 800 Newton. So from here we have to make m as the subject. The value of m is gonna be 1228.586 kg, or if you round it off, it's gonna be 1230 kg. So that's how we can find out the value of the mass of the car, the value of m. Fine. So we're done. So let's move on to question B. The resistance force on the trailer is 200 Newton. Just on the trailer, the resistive force is 200 Newton. Find the tension in the tow bar between the car and the trailer. So let's draw the figure again for better understanding. So that's the car and that's the trailer. And now at first you need to understand the direction of tension, how we can understand what should be the direction of the tension that is being working on the car and the trailer. So think about it. The car is pulling the trailer. The car is pulling the trailer. So that means the car is creating a tension on the trailer in downward direction. The car is pulling the trailer, so that means the car is creating a tension on the trailer in the downward direction. So according to Newton's third law, the trailer is going to apply tension force in upward direction. And the value of tension in both the cases, it will be definitely equal, because according to Newton's third law, we know that action and reaction pair is always going to be equal. So at first you need to sort out the direction of the tension. And only on the trailer, the resistive force is 200 Newton. Only on the trailer, the resistive force is 200 Newton. So we have to find out the tension. So on the trailer, think about it, on the trailer, in the upward direction, resistive force of 200 Newton is acting. And in downward direction, tension is acting. And also in the downward direction, the mass of the trailer was 300. So 300 G sine 3 degree, it's also acting in the downward direction. So the equation will be T plus 300 G sine 30 equals to 200 Newton. So now just solve it. It's going to be 42.99 Newton. If you round it off to 3 significant figures, it's going to be 43.0 Newton. So that's the answer. So we are done with question 3. So let's move on to question 4.